Hello everybody and welcome back to the maths videos. We have reached day 17, so only 3 left to go. So let's crack on and see if we can get through the orange questions first of all from the day 17 problems of the day. So as we can see in the first question here, Mary measures the mass of 2 cylinders. So let's think what mass means. If we're measuring mass, we are measuring the weight of something, so how heavy those cylinders are. What is the mass of 10 of these cylinders? Now this one might be quite tricky for you to see in the video if you're finding it hard to read the scales. I'll help you out by saying that each of the black notches here is 1 kilogram. So 1 kilogram, 2 kilograms, 3 kilograms, and so on. So we can see from the diagram that 2 of the cylinders weigh 7 kilograms. So 2 cylinders weigh 7 kilograms. But we want the weight of 10 cylinders. So we have to think, how do we get from 2 to 10? How can I turn 2 into 10? And if I do that, because I have an equal sign in the middle, I'm going to have to do the same to the other side to make sure they are equivalent. It might help to think about this one visually. So we might show that we have 2 cylinders and between them they are 7 kilograms. Well, if I drew out some more lots of 2 until I had 10 cylinders, now I've got 10 cylinders. Now I know that a block of 2 is 7, so I also know that this block of 2 is 7 and this block of 2 is 7 and so on. So all these blocks of 2 are 7 kilograms. So what we're really working out here is how many groups of 2 does it take to get 10? Well, we have 1, 2, 3, 4, 5. So we have 5 groups of 2. Each group is worth 7. So we have 5 lots of 7. So we are going to do our times tables, 5 times 7 or 7 times 5 if it is easier, which would tell us the weight of 10 cylinders would be 35 kilograms. The other way you could have done it is to work out what one block must have been worth by halving 7. That would give you 3.5 kilograms. Then you times your 3.5 by the 10 and you get to the same answer of 35 kilograms. Okay, it's another one of the days where the orange questions only have 2 instead of 3 questions. So let's have a look at Jack and Dora for question 2. So Jack and Dora each have some money. Dora says, I spent half of my money. And Jack says, I spent £12. So they have the same amount left after they've done their spending. Dora spent £20. So how much money did Jack have at the start? So there was lots of information in that question. So again, we're going to think about what we know, what we need to know, and our calculation. And we're going to think about what we know by putting it down visually to help us. So I'm going to start off with a bar to represent Dora's money. So I've got a blank bar at the moment for Dora's money. And if I look at Dora's speech bubble, it tells me that she spent half of her money. Well, what do we know about the fraction half? It means cutting into 2 equal groups. So I'm going to put a line down the middle so that we've got what Dora spent and what Dora has left. So what Dora spent, what Dora has left, and they are equal. I'm actually told how much Dora spent, which is £20. Now, if these 2 groups are equal, because she spent half of the money, if she spent 20, she also has £20 left. Okay, now we need to think about Jack's bar. So Jack, we are told, has the same amount left as Dora. So first of all, I'm going to label that bit on the bar there. Because he has the same amount left as Dora, he must have £20 left. We're also told in his speech bubble that he spent £12. So I'm going to put that on there. And you'll notice I've made his bar shorter than Dora's because I know 12 is less than 20. Now, lastly, we were asked how much money did Jack have at the start? So what we want is the amount of Jack's full bar. So one part is 20 and one part is 12. What is the whole? To get the whole, we add the two parts. So we do 20 plus 12. And I've used column addition there to work out that Jack started with £32. So as you draw it out and label it as you go, you work towards the answer just by labeling the right part of the diagram. Okay, that is orange questions done for day 17. That felt really quick. Let's have a look at the blue questions though. So there are 3 blue questions today, and we're back with Jack and Dora to start. So Jack and Dora have some money, but it's different amounts this time. We are told that Dora spent 1/3 of her money, and Jack spent 1/4 of his money. Again, they have the same amount left at the end. Dora spent £72. So how much money did Jack spend? So again, we're going to draw this out visually and think about what we can label where. So I'm going to start with Dora's bar again. So I'm going to draw out a bar for Dora. And this time, Dora says that she spent 1/3 of her money. So how many equal groups do we need to cut this bar into? That's right, we need to cut it into 3 equal groups. And then we see that she spent 1/3. So I'm going to write spent over that one. And I'm going to write left over those 2. So she spent 1/3. So how many thirds does she have left? That's right, £72. Sorry, 2/3 left. The next part we need to label is the £72. Is £72 what she spent or what she has left? We are told in the question it's what she spent, so it belongs in this block, the 1/3 block. 72. Okay, before I work out anything else on hers, I'm going to draw out Jack's bar. So again, we are told that Jack has the same amount left. So he must have a bar at least this big because he has the same amount left. Now we're told that he spent 1/4. So if he spent 1/4, how many quarters does he have left? Let's think about Dora. She spent 1/3 and had 2/3 left. Jack spent 1/4, so he has 3/4 left. So we're going to split that bit into 3 and then put the other quarter on there. Okay, so now I've got Dora's bar and Jack's bar. So now I need to think, what can I work out? Well, the only number we have on here so far is that Dora spent £72, which is 1/3. Now we know that all these blocks are equal. So if this block of Dora's bar is 72, this one is 72 and this one is 72. So I'm going to label those up. So now we've labelled them up, we can work out how much money Dora had left by doing 72 plus 72, or 2 times 72. So if it's easier, we can do that in column addition. And I'm going to start with my ones column. 2 plus 2 is 4. 7 plus 7 is 14. So Dora has £144 left. So Jack also has £144 left. Now, I have popped that label on the bottom there to show that Jack also has £144 left. But what fraction of Jack's money did the £144 represent? It was 3 groups out of 4 So this is 3/4 of Jack's money. The amount he spent was 1/4. So he spent 1/4. He has 3/4 left. What could we do with our 144 to turn it from the 3/4 into 1/4? We need to share it equally between the 3 groups because each of these is the same as or equal to this one. So we are going to do our 144 divided by 3 or shared into 3 groups. I'm going to use bus stop to help me do this one. So I start off with 3's into 1, which I can't do, so I move over and put them together. 3's into 14. If I do my 3 times table, 3, 6, 9, 12. I can fit 4 lots in, and I have 2 left over between 12 and 14. Now I need 3's into 24, which is 8. So I now know that 1/4 of Jack's money is £48. So we were asked how much he spent, which is this block here, and this block is £48. Jack spent £48. So it might look complicated, but draw it out and label up what you know in the right place. Okay, now this is quite a challenging question. I had to do some spinning of my whiteboard and really think about this one. Now we have been asked to find the area of the blue triangle, which is just shaded in the middle here. And we have been given a grid square around it and the length of each of the squares within. But how do we get to the triangle? Because the triangle is cutting up these squares in all different patterns and proportions. So I can't just count the squares because this chunk isn't as big as this chunk, or that's smaller than that chunk. So that's not going to work. We need to think about what we know about the formula for the area of a triangle and what we know about the formula for the area of a square. So I'm going to start off by drawing out roughly what they have onto my whiteboard. So we've got this grid square, which has 4 columns and 4 rows. Okay, they then have this triangle that goes from the top right corner, and then it goes down to the bottom line and then down to the left line. So I won't be able to copy this exactly, but I will try and get it as accurate as I can. Oh, I'm quite proud of myself with that one. Okay, so what I'm going to do here is use some colours to help us, because we know that the area of a triangle equals base times height divided by 2. And we know that the area of a square equals length times height. So I'm going to put those two onto my whiteboard. So we now have the matching picture and we have the 2 formula that we need. So the area of a triangle is base times height divided by 2. The area of a square is length times height. Now, the triangle we're focusing on is this one I've coloured in black in the middle. But some of you may have spotted that we can make some more triangles out of what is left in the picture. Apologies for my non-straight line. So I'm going to use some colours to make this a little bit clearer. So let's call the red one triangle A. I'm going to colour in a blue one. And that's going to be triangle B. And I'm going to colour in the green one to be triangle C. Now, if you look at my diagram, we can see that we have a base, then a right angle and a perpendicular height. So it means at 90 degrees, we have a base and a height for this triangle, because what we know from the diagram is that each of the squares within our grid is 1 centimetre wide and 1 centimetre tall. So let's have a look at triangle A here, and I'm going to hold it this way around and make this the base. How many squares on the base? It's right, 1. So the base is 1, the height is 1, 2, 3, 4, and that's all divided by 2. So the area of the red triangle is 1 times 4 divided by 2. Well, 1 times 4 is 4, divided by 2 is 2. Okay. Well, that's the red triangle done. I now know that this is 2 centimetres squared, this red bit. What about the blue triangle? Again, I can keep it this way round and I have a clear base and then at 90 degrees a height. So the base for this triangle might be hard to see now I've coloured it in, but it's this one over here on the diagram is 1, 2, 3. 1, 2, 3. And the height, 1, 2. So if we plug that into our formula, we end up with 3 times 2 divided by 2. Well, 3 lots of 2 is 6. And then I divide it by 2 and I get back to 3. Okay, so the area of the red triangle is 2. The area of the blue triangle is 3. What about the area of this one? It's hard to see a base unless I do this with my whiteboard. Simply by turning my whiteboard 90 degrees, I can see I have a base, a right angle, and a height. So it's important to remember that the base isn't always what's at the bottom. You can turn a triangle round and the base and the height must be perpendicular. It must have 90 degrees. If we hold it this way, we can see that our base is 1, 2. And to show you on the original diagram, it's this bit over here. We've now flipped it, so this is on the bottom. So our base is 2 and our height is 1, 2, 3, 4. 1, 2, 3, 4. So now we have 2 times 4 divided by 2. Well, 2 times 4 is 8, divided by 2 is 4. So we have now worked out the red section has an area of 2 centimetres squared. The blue section has an area of 3 centimetres squared, and the green section has an area of 4 centimetres squared. Now, some of you might have jumped to the next step and seen how this is useful, but we have to remember that the question actually asks us for the black bit, not the red, green or blue bit. So the other thing we need is this formula here, the area of the square. The area of the square is its base or its length times its height. So the bottom is 4 and the height is 4. So the area of the square equals 4 times 4, which is 16. So let's think about what we know now. The whole square is 16. The whole square is made up of red, blue, green and black triangles. We know the red, the blue and the green. So if we total these and take them off of the square, we will be left with the black triangle. Let me just rub out the formulas now we've used them so I can demonstrate that over here using our bar modelling. So what we're saying, oh dear, my black pen's running out. What we're saying is that the area of it all is 16. There is a red part, that is 2. There is a blue part, that is 3. And there is a green part, that is 4. So to work out the black part, we need to find the missing part. So if we do our total parts, 2 plus 3 plus 4, well, 2 plus 3 is 5, and 5 plus 4 is 9. So these total to 9. So all we need to do now is find the difference between 9 and 16 for the black part, which is the triangle we were asked to find. So the difference between 16 and 9 is 7. So the area of the triangle is 7 centimeters squared. So there were lots of steps in that one, but I'm hoping that the colours have helped you see how we worked out the triangles, even if we couldn't use our normal triangle formula for the black triangle straight away. Okay, one question left then for day 17. Question 3 says, write down all the common multiples of 4 and 6 that are less than 50. Show or explain your method. So have a go at this one, see if you can explain to someone or write it out on your piece of paper. How do you get these? Well, let's first examine the terminology. What is a multiple? So a multiple of 4 and 6 is a number that is in the 4 and 6 times tables. It means that 4 will multiply into it without leaving a remainder. And we are looking for a common multiple because we want a number that will be in the 4 times table and be in the 6 times table. So one way you could go about this, because I know that these are some of the times tables we find a little bit trickier, is you could write down your 4 times tables. So I could start counting and say, well, 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 20, 24, 28, 32. I'm going to stop there, even though you do need to go all the way till 50, but I'm going to stop there because I've run out of room. But here we go, I've got my multiples of 4 up to 32. But as I say, keep going to 50 on your paper. The next thing I'm going to do, I'm going to write out my 6 times tables. So 1 times 6 is 6. And remember, if you forget your times table, you are just adding on another lot of 6 each time. It's repeated addition. So I'm going to add 6 to that to get 12. I'm going to add 6 to get 18. 24, 30. I managed to make it to 42 this time before I ran out of room on my whiteboard, but I should have kept going to 50. Now, for common multiples, I need to look along my list and see any that are in both the 4s list and the 6 list. I can start with 4 and see that 4's in there, but it's not in there, so I can get rid of that. 8 is in here, but it's not in here, so I can get rid of that. 12 is in this list and this list. So I'm going to circle 12 and I'm going to get rid of the 6. And so you can keep going along. 16, no, 20, no, 24. Yes, okay. So 24 is in both. Now, if you've written out your list to 50, you can just keep following along and circling every time you get to a number that's in both. But I want you to see if you can think of another way that you'd have found the common multiple based on the first number I found there. So I found that 12 was a common multiple, and then I found that 24 was a common multiple. Any idea what would have been my next common multiple? It's 36, and I think there's one more before we hit 50. It's 48. Do you notice anything about this number sequence? 12, 24, 36, 48. This is my 12 times table. So because 12 was the lowest common multiple, the lowest number that both 4 and 6 are factors of, once I got there, I could then use that 12 to keep my jumps and find out my common multiples. I've had to stop at 48 because if I add another 12 on, that takes me to 60, and that is too big. So 12, 24, 36, 48 are your common multiples. Fantastic stuff. There were some really tricky questions in day 17. I think as they're getting to the end, they're trying to challenge us more. So that is it for the video today. Do come back for the last 3 videos, and then I've got some other maths challenges planned for us. Thanks very much, everybody. See you soon. Bye-bye.